Okay guys, welcome back. So we're going to finish up 4B. So we were talking about the difference between an investment or a principal or a balance that earns simple interest versus compound interest. And we had looked at an example in which we calculated the future value of an investment that only earns simple interest, okay, over a 20-year period. So we used this formula right here, and we basically we're going to start using formulas to calculate the future value of an investment that earns compound interest. Okay, before we do that, I thought about this last time. I wanted to show you my calculator here. So what I did, if you think back to the table right here where we manually calculated these values, I pulled this up on the calculator, okay? And because I wanted to show you the difference in how these two investments grow. So if you remember, we're depositing $1,000, and at the end of the year, for the simple interest, we get $100 each year, okay? So this grows linearly, or about the same amount each year. But an investment that earns compound interest grows like this. And if you notice, these are the same values that we got in the notes. And notice what happens as we come down here, as the number of years increases. So, you know, at 10 years, there's not a whole lot of difference. There's close to $600 more. But let's look at 20 years. So at 20 years, there is more than double, okay? So you got $3,000 versus $6,727.50. And if we keep going down after 30 years, now we're really starting to see some growth. This is quadruple the amount. So you got $4,000 in the account earning simple interest, and then over here you've got about $17,500, and then let's scroll down to, let's look at 40 years. So yeah, 5,000 versus, look at this now, 45,000. So that's 9 times the amount. Okay. So anyway, I just wanted to show you that to illustrate the difference in growth there. All right, so we looked at how to calculate compound interest by hand. Okay, you have to do it step by step for each particular year, but that's not very efficient. Okay, so what we're going to do now is look at some formulas to figure out the future value or the accumulated value of an investment. Okay, all right, so we know A again represents the accumulated value. P represents the principal, the APR is the interest rate, and then Y represents the number of years. Well, look where Y is in this formula. It's in the exponents place, as opposed to this formula for simple interest, it's not in the exponents place. And that's what causes the difference in growth, okay? That's where we get this exponential growth. Okay, so when you're doing these guys, it's going to be essentially the same. You're just going to plug the numbers that you're given into your formula, plug it into your calculator, and it's going to give you the future value or the accumulated value, in other words. Okay. All right, now I do want to point out here, this is the formula that you're going to use when interest is compounded once a year. Okay, and we'll talk more about what that means here in a minute. That just means that when it says compounded, that just means that interest is credited to your account once a year, okay? Because typically it's done more like on a monthly basis, and we'll look at that here in a minute. All right, so let's look at example 2. It says use the compound interest formula to compute the balance in each account after the stated period of time, assuming that interest is compounded annually. So the word annually means once a year, okay? So we're going to be using this formula right here. So again, you can identify your parameters here. P is 20,000, that's how much we're investing. The APR is 3.5%. I'm going to go ahead and convert this to a decimal. So if you move that decimal to the left 2 places, it'll be 0.035. And then this is over a 20-year period of time. So y is going to equal 20. Okay. So I'll rewrite my formula down here real quick, and we'll plug in those numbers. Oops. Okay. All right, so A will equal the principal, which is $20,000, times 1 plus APR as a decimal is 0.035, and then Y is the exponent, and it's 20. So we're raising this to the 20th power. All right, so I'm going to get my calculator. And again, let me just reiterate that having this calculator, this app on your phone, is really going to help you with these. Because all I have to do is literally plug in exactly the way it's written. And it'll calculate it for me. Okay, I'll close these parentheses, and then this is my exponent key, so I'm going to raise it to the 20th power. Then I'll just hit enter, and this will give me the future value. Okay, so you can see that after 20 years, this has grown to almost $40,000. It's $39,795, and let's round this to the nearest cent. Okay, so that would be the hundredths place. So this 7 right here will bump this 7 up to an 8. So this will end up becoming 78 cents. Okay. So this is over a 20-year period. Our money has almost doubled. Now guys, in the real world, if you're saving for retirement, over the long run, or on average, you can get a lot better than 3.5%. Okay, if you're investing your money properly. Typically, you can get, on average, more like 8, 9, 10%, and that can make a huge difference. So, anyway, all right, so this is an example in which interest is compounded once a year. So again, just remember, that means that interest is credited at the end of the year. But what if that weren't the case? What if interest were credited every month, or every day even? Okay, so that's where we end up with this formula right here. Now the only difference between this formula and the previous one is this n right here. The n's in the exponents place, and there's also an n being divided into the APR. Okay, so n represents the number of compounding periods per year, or in other words, how many times is interest being credited to your account. Okay, so think back to that credit card example in 4A. What we had to do in that example was we took the interest rate, we divided it by 12, and then we multiplied it by the balance, and that gave us the interest for that particular month. So this is similar. Okay, so let's go ahead and list some values for n depending on the frequency with which interest is compounded. So if interest is compounded daily, then that means there will be 365 compounding periods in a year. So that's the value that you would use for n in this formula. And then if interest is compounded monthly, there's 12 months in a year, so there would be 12 compounding periods. Okay, so you would plug a 12 in for n. And then quarterly means 4 times a year. Okay, or in other words, 4 periods, 4 compounding periods. And then finally, guys, semi-annually. That means twice a year. Okay, so 2 times a year, or in other words, every 6 months, essentially. Okay. Really, what this formula is, this formula would turn into the above formula if you let n be 1. Okay. Because the APR divided by 1 would just be the APR, and then y times 1 would just be y. Okay, so interest being compounded annually is sort of a special case. So that's why they give it its own formula up here. But you could just use this one and use a 1 for n. Anyway, this is the formula that you use to determine how much money you're going to make if your account earns compound interest. Okay, a lot of people don't know this. They may have learned this one time in school and then they forget it. All right, let's look at example 3. So example 3, it says we've got $4,000 that we're going to invest for 5 years with an interest rate of 3%, and this is going to be daily compounding. Okay, so I know this formula by heart, so I'm just going to recopy it real quick up here so we can see it. So the accumulated value is equal to the principal times 1 plus the APR over lowercase n, and then we're raising this to the power of n times y. Okay, so P is $4,000, y is 5 years, and then my APR as a decimal will be 0.03. And again, this is kind of a low interest rate. This is not real great. Now this would be great if you're borrowing money, right? Okay, because when you're borrowing money, you're on the opposite end. You're paying someone interest, plus you're trying to pay that principal back. All right, well, if I plug these numbers in, I'm going to have A is equal to $4,000 for P times 1 plus the APR divided by 365, because this is daily compounding. Okay, and then we're going to raise this to the power of 365 times the number of years, which is 5. Now, if you're trying to plug all this in one step in your calculator, it might be a good idea to keep everything in the exponent in parentheses there. All right, so I'm going to plug it in exactly the way it's written. 4,000 times in parentheses 1 plus 0.03 divided by 365. Close those parentheses, and we'll raise this to a power. Now, if your cursor goes up there in the exponent's place, then you don't have to keep this in parentheses. Okay. And some of the older calculators, they don't actually put the cursor up there. And so, in that instance, you would need to use the parentheses. And I'll say times 5. See how all that stays up there? And we'll hit enter. And this gives me my balance. It becomes $4,647. And if we round that to the nearest cent, that's going to become 31 cents. Okay, so you can see this one hasn't grown all that much, right? For one thing, the interest rate's not great, and for another thing, we only left it in for 5 years. When you're talking about investing, guys, unless you're like speculating and trying to really gamble and get rich quick, general investing requires time before you can really start to see those big gains. And so that's why you guys, you younger students, really need to start thinking about going ahead and start saving for retirement. And look at it this way. You may think, oh, I'm 18, I've got plenty of time. Well, go ahead and start saving and investing now. Maybe by the time you're my age, you'll have so much money you won't have to work anymore. Okay? Think about it like that. All right. Well, let's do another one like this. So example 4, we've got $10,000. We're going to invest it for 5 years again at an even smaller interest rate, but we're going to have monthly compounding. Okay? So n in this case would be 12. Okay? I'll go ahead and write the APR as a decimal. Y is 5 years, and the principal is $10,000. All right, so I'm going to recopy from that formula up there. I'm investing $10,000. I'm divide this by n, which is 12, and we'll raise this to the power of 12 times 5 years. And we're going to let the calculator do the work for us. And I'll show you something here, guys. If you want to, you can hit second and then the enter key for entry, and it'll let you go back and modify this one. So instead of having to retype everything, I can just type over some stuff, and I can hit the delete key when I need to. Okay. And over here down in the denominator, I'll put 12, and I'll delete that 5. Then over here for the interest rate, 0.27. Well, now I need to insert. So the insert key is right here, but you have to hit second first, and then hit a 5. Okay. Well, I need to insert again though, because I'm leaving out my. Oops. I need to insert the division, and then I need a 1. There we go. Okay. I think I got everything set up. Oh, and I need to change the principal, right? I need to go ahead and insert another 0 there. So maybe it would have just been easier if we had just redone the whole thing. Anyway, I've got it all in there now, so hit enter. All right, so this one didn't grow too much either, did it? It went from 10,000 to a little over 11,000. And again, it's only 5 years. The interest rate's small. So this would be $11,472.21. Okay. All right, now before we look at the last couple things real quick, I want to show you something with this example here. So let's say we keep the 10,000, but I change the interest rate a little bit. Or actually, first, let me just come back in here. Let me just change the number of years. So instead of 5, let's change this to 20 years. See how much we would have. So after 20 years, we still wouldn't have all that much, 17,000, because the interest rate's so low. Let's do it again, and let's try for 40 years. Okay. Well, now we've only got 30,000, but that's not much. That's not really acceptable. So now let's go and change something much more powerful. Well, both the interest rate and time kind of work together. Okay. So let me come back in here. Let me change this interest rate to something more respectable. Let's say 8%. I'm going to delete the rest of this. And let's change this back to just 5 years to start out. Okay, so 8% for 5 years, and let's see what we get. All right, so we're about at $15,000. That's a lot better than what we had earlier. Okay, let's go back in and let's change this to 10 years. Now we're really starting to move. We've got $22,000. Okay, so I'm going to go back in. That's only 10 years. Let's jump this up to 20 years because we've got this better interest rate. Hit enter. Now we've almost got $50,000. Okay, so that's only 20 years. Now let's say that, something more realistic, say 40 years. Let's see how much. Now look at this, guys. $10,000 over 40 years turned into $242,000, almost $243,000. That's $250,000 essentially, with just $10,000. Because we had the time, we had 40 years, and we had a relatively decent interest rate. Now, typically, when you're preparing for retirement, you don't just deposit $10,000 when you're 18 and forget it. You're continuously depositing money, investing money. So that can really grow, okay, into $1 million or $2 million or $3 million. And you don't have to have made a lot of money to be able to end up with that kind of money in retirement. All right. Okay, so now we're going to talk about something called the annual percentage yield. So we've seen the annual percentage rate, that's the interest rate. The annual percentage yield is actually, it's called the effective yield. This is actually how much your money will actually increase by, the percentage by how much your money will increase. Now, this will be the same for the APR if interest is compounded only once a year. But if interest is compounded more than once a year, like monthly or daily, then the APR is not the same as the APY. The APY is actually a little bit higher. And that's because you have several compounding periods within that year. So any interest earned ends up earning its own interest. Okay? So it makes that annual percentage yield a little bit higher. But in any case, you do have a couple questions in which you have to find the annual percentage yield, and this is the formula to do it. Okay, I'm not going to go into this, but basically you'll be given the APR. You'll know the number of times interest is compounded per year, and you just plug those in, evaluate this, and this will give you the annual percentage yield. And guys, next time you're looking at, like a credit card or a savings account or anything like that, look and see if they list the APY instead of in addition to the APR. Okay. All right. Well, let's look at this example 5. It says find the annual percentage yield. So a bank offers an APR of 2.66 compounded monthly. Okay, so it says do not round until the final answer and then round to 2 decimal places as needed. All right, well, I'm just going to use this formula. So compounded monthly, that means that N is going to be 12. And of course, the APR, if we convert it to a decimal, will be 0.0266. And I'm going to plug it into my formula. So the annual percentage yield will be equal to 1 plus the annual percentage rate divided by 12. And we'll raise this to the 12th power, and then I'm going to subtract 1. Now, I do want to tell you, when you get this, it'll be a decimal. So you're going to have to convert it back to a percentage by multiplying it by 100. Well, let's just plug all this into the calculator. Okay, open your parentheses. We're going to say 1 plus 0.0266. We'll divide that by 12. We're going to close these parentheses. We're going to raise this to the 12th power. Now I'm going to get out of the exponent, and now I'm going to say minus 1. Okay, it's very important that you do that. So now when I hit enter, let's write this down. Let's carry it out to a few decimal places. 0.0269. What else? 267. Okay, so this is the decimal. We need to convert it to a percentage, so we'll multiply it by 100 or move that decimal to the right 2 places. So if we do that, it'll become 2.69267%. It is now a percentage, but this says round to 2 decimal places. So my second decimal place is right here. So there's a 2 behind it, so we're going to keep it a 9. So it's going to end up being 2.69%. So this is the APY. This is the actual amount that your money will increase in 1 year if interest is compounded monthly. So you can see it's a little bit more than the APR. Okay, and it always will be unless it's only compounded once a year, and then the APR will be equal to the APY. Okay. All right, well, we've got one last thing to talk about, and this is entitled Planning Ahead with Compound Interest. So the gist of this, guys, is that, okay, you want to invest some money today such that you have X amount of money so many years in the future. Okay, so this could be like a kid's college fund. So let's say, you've got an extra $10,000 lying around, and when your kid is born, you want to invest that $10,000, and you want it to grow to a certain amount in the future. I'm saying it backwards. No, let's say you want to have a certain amount of money available in the future. So in the context of that example, you want to make sure that when your kid turns 18, they have $100,000 in their college fund. So then the question is, how much do you need to invest right now, such that in 18 years, that investment will grow into $100,000, okay? So see, we're basically going in reverse of what we've done previously. So look at this formula. So instead of them giving us the principal is what we're trying to figure out. We're trying to figure out how much money do we need to invest such that we have this accumulated value in the future, okay? And of course, we'll have to know the interest rate, and we'll need to know the number of years and also the number of times that interest is compounded per year, okay? And this one is actually, this example is similar to the one I gave. It said, how much must be deposited today in the following account in order to have a $110,000 college fund in 14 years? Assume that no additional deposits are made. So this is where this example is not real practical, because typically when you save up for something, you save along the way, right? You make deposits along the way. You don't just put a bunch of cash down and then forget it. But anyway, and it says the account, it says an account with quarterly compounding, so that means 4 times a year, and then an APR of 6.14%, okay? So guys, A, or the accumulated value, is this $110,000. This is what we want to have 14 years from now. And what we're trying to figure out is how much we need to invest right now. Okay, so we're going to plug these numbers into this formula right here. So the principal, or in other words, the amount that we need to invest today, is equal to the future value that we want to have 14 years from now, which is $110,000, over 1 plus the APR. Now as a decimal, it'll be 0.0614 divided by 4, because quarterly compounding means 4 times a year. I'm going to raise this to the power of 4 times 14 for 14 years. Okay? And you want to make sure that all this stuff stays in the denominator when you're doing this. Okay, so I'm just going to use the calculator. I'm going to say 110,000. Divide this, open my parentheses. I'll say 1 plus 0.0614. And I'll divide that by 4. Close those parentheses, and I'll raise this to the power of 4 times 14. You could go ahead and multiply those. I know that'll be 56, so I'll just do it in my head. And I'll hit enter, and this is the amount. It's $46,871, and if I round to the nearest cent, it would become 56 cents, okay? So that's the amount. And when you're doing these, guys, your answer should always be less than the future value, right? Okay. So this is basically means that if I invest this amount right now for 14 years with quarterly compounding at this interest rate, then I would have exactly $110,000 in the future, okay? So anyway, you could think about this, if you're you're trying to save up for a house or a deposit or anything like that. Of course, like I said, this isn't real practical because typically when people save for something, they're continuously depositing, right? But anyway. All right, guys, well, that concludes this section, okay? So we have one more section that we're going to talk about in Chapter 4, and that is really concerned with debt. We'll talk about credit cards again, mortgages, things of that nature. And also the nature of how the principal and the interest paid on a mortgage, or any loan for that matter, how they behave during the duration of the loan. Okay, it's interesting. Anyway, I'll see you in the next one.